It's recording. Here we go. Exercise 4G. Let's see what you need to know. So 4G is determining rules, very similar to transformations and everything beforehand. Let's see what you remember from our last session. So last session, I talked about even functions, odd functions. Remember I gave you an x to the power of 7 graph, and I said, can you predict what it looks like? Well, here's a graph. And just look at the x-intercepts. There's a couple things you should be able to determine already. What is the equation, or what should you expect the equation to be? What goes in the brackets? Hands up if you know. Adrian.
X minus 3.
Very good. We need an x minus 3 in order to end up with an x-intercept at 3. And what's another little detail we must have?
You've got to have plus 18 somewhere. Because, well, x minus 3 squared, and then plus 18.
Oh, okay. So this is interesting. So Lucky noticed that here is 0, 18. So when x is 0, the question is the y coordinate 18? Now you can have a plus 18 if it was a general equation, so ax squared plus bx plus c. Yes, that would have to be 18. But in this case, we need to double check if it's already 18. If it's not 18, then yes, you're right. It'll be missing an extra constant value there. So let's see. If x equals 0, do you get 18? You get 0 plus 2 times 0 minus 3 squared. And why do we have the square? The square is because it's a turning point. Okay? And so you would actually end up with 2 times 9, and conveniently it does actually equal to 18. So it means you don't need an extra plus c. But if it wasn't, then that was a good detail to focus on, to double check any coordinates, whether there's a dilation or not. So hence, double check then, see if you are missing an extra piece. Okay? But there you go. So our equation is already done by simply knowing axis intercepts and the properties from last session. So hence, it should just be x plus 2 times x minus 3 all squared. Cool? Next one. Now this one is a typical exam question. I'm going to pause the video and have you to think. How would you do this question? Tech-free. Okay, so it's not an exam question here, but sorry, let me fix that. Because it's tech-free, you will never find that question in a tech-free. You will normally find this as a multiple choice question in an exam, tech-enabled, but I've put it into tech-free because you can do this without a CAS. All right, so I'm going to pause the video. All right, here's a little trick. What's the question asking? It's tough to figure out what this D is because you don't know what the graph looks like. But if you think about transformations, you can think of it as this is your graph. It's almost like, I'll do a synonymous one. If I told you this is your function, x squared, right? In your mind, this is what you're seeing. You're seeing that's an x squared graph. But then as soon as I say plus 1, and I ask you, what does that look like? You would say that moves up by 1. So you would tell me the graph now looks like this. True? So that means the first part is what the graph looks like. And any additional constant, what it does is it shifts up and down based on transformations. So I could have changed that question to x squared, and I could have said, find when x squared plus d to have 2 distinct solutions. So what am I saying? I'm saying, what would d have to be so that my graph will have 2 x-intercepts? If that was my question, it was obvious that the only way to get 2 intercepts is it's below 0. So as long as d is less than 0, that would work. So going back to your question then, you just need to figure out, well, what does x cubed minus 6x squared, what does that look like? Because if you can visualize what that looks like, then this plus d just shifts the graph up and down. This is a cubic graph, so if I factorized it, this would be what, take out x squared as a common factor, you got x minus 6, and that tells me from our last lesson, there is an x-intercept at 0, but it's a turning point because it's squared. It's a quadratic factor. And then this is a linear factor, crosses through 6. So what's my graph? Well, it's a positive cubic, so it should look like an N shape, but it has to have a turning point at 0, and it must cross through 6. Now that's what that part of the graph looks like that I've highlighted in yellow. So answering the question again, D is the number that moves it up and down. Now what do they want? They want, what should D be so that you have 3 x-intercepts? Because at the moment I only got 2. 1, 2. So at minimum, if I want to have 3 x-intercepts, what do I have to do? what would D have to be? If I have to shift this up or down, what would D have to be in order for me to have 3 x-intercepts? Is it up or down? Up. Doesn't make sense to go down. If I went down, it would be like 1 x-intercept only, right? So it can't be, D can't be less than 0, because if I keep going down, it can't be B, can't be 0 of 32, oh wait, 0 of 32, well I guess D 0 is right now, so that won't work. But between 0 and 32, Y32 is likely, one of the turning points is probably at 32, so if you go up and down, so greater than 0, if you keep going up greater than 0, the problem, why A can't be the answer, is because at some point, you only have 1 intercept. So you can't go up infinitely. There has to be a point. The maximum you can get to is this point. True? That's the only way you can get 1, 2, and then 3. So it has to be less than whatever this final value is. So it's likely D. Does that make sense? Okay, so that's a very typical exam question. It's about you analyzing that part and saying how many solutions there are. And often they do a cubic. So I haven't seen a quadratic version, but that was my other way of explaining the logic. And this one would be very similar. So it's about you knowing your polynomials, what a cubic looks like, understanding transformations, and then analysis. Yeah? All right, let's try another one. And this is our last question for today. Now, this one, on the bottom I already gave you the CAS work. Oh, remember, all of this is all these notes are on OneNote, so if you wanted to have a look, it's all there again. For this question, it's really just a bit of pain. You are required to know how to do this. They don't always do it, but sometimes they do. You have to do a lot of simultaneous equations, okay? And it is required. So sometimes you have to do 2 simultaneous equations to solve it. Yep.
This one's pretty good. This one works out really good.
Oh, does it? I haven't tried it, so we'll see how it turns out then. Otherwise, this is the CAS. If it's on a CAS, if it's a CAS exam, then this is how you would do it on a CAS. Let's see if you can do it by hand and get 2, -1, 1, and -2. Have a go. So Pat said it's meant to work out nicely. I'm going to give you, let's give you 3 minutes. So it's 10:42. Let's have a go. 3 minutes, see if you can solve this. I'm going to pause the video and I'm going to, everyone should be able to get the first one. D equals -2, just from substituting 0, -2 in. So everyone should know that D is equal to -2 there. So that's what I did over here. Then the next steps, everyone could be doing it differently, but I subbed in the points. So 1, 0, 1, -6, and 2, 12. These are my 3 equations that you can see. Those are my 3. What was nice is that that's A plus B plus C, and that's minus A minus C. So I can see by elimination method, A's and C's can cancel out if I add 1 and 2. And therefore you can find B straight away. So that's what I did. I said, all right, well, since 1 plus 2, these two are going to cancel out, I will end up with 2B, that's a -4, that's a -6, and naturally B equals -1 just from that first step, because it eliminates 2 variables. And then I thought, all right, well, now that I know what B is, then I just resubstituted back into 1, 2, and 3 again to simplify the problem. And we can see that by putting back B, I've got A plus C, and these 2 is -3, so I moved it across. So 3 equals A plus C. I subbed into equation 2, B is -1, so again, -3, add 3 on both sides, so -3 equals -A minus C. What's the problem? Why you can't equate these 2? You already solved B from using these 2. If you try to do it again, they'll just cancel out, right? So it doesn't work. So you have to use this for the third one. So I sub B into the third equation, and it simplifies nicely to 9 equals 4A plus C. So I've got an A and a C, I've got an A and a C. You choose how you want a simultaneous. I like the fact that this is already a minus and this is a positive. So if I add these 2, I'll be able to solve for A. So then I said, take new equation 2 and plus new equation 3. Add these 2 together, the C's will definitely cancel out. So I wrote it again, so it's a bit clearer. These will cancel out. 4 plus -1 is 3A, and then 9 plus -3 is 6. A turns out to be 2. And how did I know C? Well, so back in here, and I can see, well, if C, A is 2, that's -2 minus what? Gives you -3. C has to be a -1. Well, C has to be 1. Sorry. C has to be 1 for that to work out. But there you go. Nice and easy. So that simultaneous is required. You are needed to know how to do that. So that could be expected in exam 1. Just being able to maneuver between your algebra to solve A, B's, and C's usually should work out something like this nicely. I haven't seen one that's been too bizarre in the exam. Your textbooks can do that though. Your textbooks might be pretty horrific. So hence, don't look at it and go, do I need to know this on the exam? No, you shouldn't take too long to do. Most times they probably just want you to do that on your CAS. Okay, so knowing how to define the function, make sure again, don't forget the times in between the letters, otherwise it doesn't work. I found with my other class, just the year 11s, they had x and they had a bracket 34 minus x, but they didn't put the times in between, which I didn't think they needed to, but it did work. So if you had, the student had was x bracket 34 minus x, like that to sketch. Interestingly enough, not putting in times didn't work for him. So it might be something for you to note. Maybe your CAS is fine with it. Some CASs might not. Just make sure to put a habit to put a times in between each one as you're doing it. Remember, if the CAS comes out as faulty, it's not the CAS, it's you. There's always something about what you're doing that is wrong. So you've got to go back and check your syntax. Okay? All right, that's it for today. That's pretty much exercise 4G, determining rules. Work at your own pace, figure out where you're at. I'm going to turn on the aircon. And once you've got a moment, I'm going to stop the video so it doesn't get recorded.